Hello, this is Dr. K. In the next two videos, we're going to go over the first two chapters of Applying UML and Patterns by Craig Larman. Chapter 1 gives an overview of object-oriented analysis and design, and Chapter 2 discusses iterative development, specifically the rational unified process. In object-oriented analysis, the emphasis is on finding and describing objects or concepts in the problem domain. In object-oriented design, the emphasis is on defining software objects and figuring out how they work together to realize the requirements. Consider a flight information system. In object-oriented analysis, you want to find and describe objects or concepts in the problem domain. Here, some of the domain concepts include plane, flight, and pilot. In object-oriented design, you're trying to take those domain concepts and turn them into software objects. To do this, you must understand how software objects interact with each other. Walking through your requirements, you decide which domain concepts become software objects and how they interact with other software objects. This slide shows three levels of abstraction: the domain concept from object-oriented analysis, the software object from object design, and the code from the implementation. Here's a short example of how to do object-oriented analysis and design. We want to build a dice game that simulates the rolling of two dice. If the result of the roll is 7, the game is won. If it's anything else, the game is lost. The steps in object-oriented analysis and design are as follows. You define the use cases, you define the domain model, you define interaction diagrams, typically these will be UML sequence diagrams, and then you define the class diagrams. Let's go through these steps for the dice game. The first thing we do is define our use cases. As this is such a simple project, there's really only one use case: play a dice game. The player requests to roll the dice, and the system presents the numeric result. If the total is 7, the player wins. Otherwise, the player loses. Next, we define the domain model. We decide that the concepts involved in the dice game domain are the player, the dice, and the game itself. We also add major attributes for the concepts. For example, a player has a name and a die has a face value. Then we loosely describe how the concepts relate to one another. A player rolls 2 dice. A dice game includes 2 dice, and a player plays 1 dice game. Next, we define interaction diagrams for the concepts. We do this by looking at each use case and trying to turn it into a sequence diagram. This slide shows the sequence diagram that we come up with based on the use case in our example. A dice game object will include a method called play. The play method calls the roll method for the first die and then gets the resulting face value. Then it does the same thing for the second die. Once it has those 2 values, it can determine whether the game is won or lost. One of the things we notice when we create the interaction diagram is that the player concept is not really needed. So, of the 3 domain concepts we obtained from analysis, only 2 of them are going to become software objects. Furthermore, the sequence diagram also determines what method those software objects will have. Finally, based on the information from our sequence diagram, we can define the class diagram. And from the class diagram and the sequence diagram, we should have a good idea of how to implement the project. And that's it. We created the use case, which we presumably obtained by asking the customer what they wanted. which, by the way, is also known as requirements gathering. Then we looked at the use case and we were able to determine the classes that should be in our domain model. This is part of object-oriented analysis, which, more broadly, is part of requirements analysis. It results in a domain model, which in turn is part of the analysis model. Knowing our domain objects helped us figure out what our software objects were going to be. We used the sequence diagram to find out how the software objects interact with one another. And from that, we were able to create a class diagram showing the names of the classes, their attributes, and their operations. We want to be a little careful here to understand exactly how Larman uses UML models like the class diagram and the sequence diagram we saw in the last few slides. Larman is a proponent of Agile Modeling, and Agile Modeling is not about using UML diagrams as documentation for a project. It's about using UML diagrams as sketches that help you understand the design of your project. This is an important distinction. In Agile Modeling, diagrams may be kept on file as records of a particular meeting or design discussion, but they're not meant to be official documentation that thoroughly describes the code and is kept up to date with the code. Agile modeling often goes hand in hand with iterative development, which is the topic of the next video.